Hi, my name's Alexander Giovannelli, and today I'll be presenting our paper titled Investigating the Influence of Playback Interactivity During Guided Tours for Asynchronous Collaboration in Virtual Reality. The motivation behind our work starts with the concept of globalization, where we can see that work contributions are now happening 24 hours a day, 7 days a week. And that's due to, skilled laborers and teams being geographically distributed. And naturally, extended reality, since its inception, has been seen as very riddled with potential for collaboration, specifically in the fact that, while not in person, we still have the ability to represent ourselves and our peers using avatars. We're able to interact with complex visualizations, such as, 3D graphs or maps. Um, and most importantly, we're able to author information across multiple mediums in the form of annotations, which can take on text, speech, images, and videos. But there kind of exists a problem in asynchronous contribution specifically. And this lies in, for instance, understanding, past user or collaborator actions and behaviors in the form of, what happened? Where did it happen inside the virtual environment? And in what order did their actions transpire? And additionally, there's a combination of natural communication cues that are lost, such as the combination of speech, gaze, gestures, and nonverbal cues. And we see this as an opportunity to expand on existing work by having guided tours where avatars act as the annotation, and the system records user actions and behaviors made by the collaborators' actions in order to provide or relay a more narrative form of the work that they performed and present the contributions readily for future observers to, for instance, observe the recording. And this allows them to understand what it is a previous user or collaborator did, learn where actions were performed, and of course, follow the order in which those actions occurred. But we need to consider how this sort of guided tour is played back to an observer. And that starts with an author controlling the tour itself, designating points of interest such that at those points of interest, information is properly consumed. And we need to follow the observer's experience, how they can engage with the guide as well as the tour, and really retain the information that is conveyed to them through that tour. And so we created our own system, and we limited the use case to be an identified interesting field for immersive collaboration in advanced manufacturing. And we specifically had this system curtailed for inspecting a 3D printed object scanned into virtual reality. And our tours would be controlled via interaction. And we follow two categories, specifically multi-scale navigation, where users could navigate down to get a closer look at a portion of the print, increasing the level of detail, as well as navigate up to get more of an overview of the print. And of course, perspective sharing, which is kind of a what you see is what I see, controller point acknowledgement, and docking a clipping plane that cuts inside the object. And these might not be clear, so we'll just go ahead and show what these playback interactions look like from our training environment. So we can see when they navigate down that they shrink in scale and get a closer look at the print, but they also can navigate back up to get more of an overview look. For controller point, just acknowledging wherever the guide tells them to look. For what you see is what I see, positioning their head positionally and rotation wise inside of the guides. And last but not least, using the clipping plane to cut inside an object and see things that would otherwise be included, putting it at a designated position by the guide. And with this system and the book of work we've identified, we had some research questions which we wanted to answer, which are specifically how does the extent of interaction during an immersive guided tour impact one, an observing user's recall of information shared by that guided tour, and two, an observing user's experience. And we designed our own experiment that was between subjects. We had 10 participants per condition, and all participants observed the same 8-minute guided tour, but with varying degrees of interactivity, starting with the lowest being passive, where the user not only had no control of the viewport of the tour, they also didn't have the ability to navigate across the multiple scales or, acknowledge any sort of perspectives shared to them. Next, we had an increment where it was rails. Users could control their viewport, but again, no interactions for reviewing or following along with the playback. Next increment was navigation, where they would perform the multi-scale navigation in order to have the playback resume. And last but not least, the interactive, where they had to perform all of those playback interactions to continue through the guided tour. Some measures that we collected from this user study were for, again, the recall of information. And we measured this by our own curated tour content test. We administered 2 of these, both containing questions regarding verbal information covered and spatial locations identified during the tour, and the user experience, where we administered surveys such as the Simulator Sickness Questionnaire, User Engagement Scale, and the NASA Task Load Index. We also had a open-ended audio recorded interview with the participants. And so using these measures, we intended to answer our initially posed research questions. So specifically regarding the information recall, we hypothesized that the interactive condition would have higher verbal and spatial information recollection than all other conditions. And for user experience, that the interactive and navigation conditions would have higher reported engagement than Rails and passive conditions. The passive condition would have a higher reported workload than all other conditions. And the Rails and passive conditions would have a higher reported simulator sickness than the interactive and navigation conditions. And so looking at our results, we can see for verbal recall that the interactive condition scored generally higher than all other conditions, but only had significantly higher results when compared to the passive condition. And for that reason, we partially support our first hypothesis. For the spatial recall, we do see that the interactive condition had participants identify the target destination indicated by the tour guide more closely. However, we also see that this closeness is replicated for the Rails condition, both compared to the passive condition. And we attribute this to a greater influence of viewport control on spatial recall. However, there was no significance when comparing the navigation condition to the passive condition, and we attribute this to participants reporting that they were performing preemptive navigations and getting lost in the space. And for this reason, we partially support the hypothesis. Moving on to the user experience and specifically engagement, we can see that the passive condition um, performs significantly worse in engagement score for subscales of aesthetic appeal, perceived usability, and reward compared to all other conditions. Um, and we attribute this to a reported absence of viewport control. And this was said to be contradicting the expectations of virtual reality systems by participants. And for that reason, we do partially support our hypothesis. For the workload, we only see significance for the frustration subscale of the task load index, and for that reason, we do not support our hypothesis. And last but not least, our simulator sickness scores. While we do see that the passive condition did have a significant increase in its simulator sickness across all of the subscales, we also see that the interactive condition had a significant increase in simulator sickness for its ocular, motor, and total subscales. For this reason, we do not support our hypothesis. So some key takeaways from our study are that when following a guided tour, interactivity positively influences recall, and that viewport control improves the user experience. And we believe that there's a lot of future work that can be done, generalizing the use case to medicine, sports coaching, and education, and as well as having multiple users participate in the system. Thank you.